All right, 9.6, adding mixed numbers with unlike denominators. Now, thankfully, this is very similar to adding regular fractions. We just have some whole numbers to consider. So, on your notes, first you can fill in the blanks. So you can write, it's just like adding fractions, thankfully, except you add the fractions and then add the whole numbers. Can't forget about those whole numbers, which I don't want to say is pretty obvious or self-explanatory, but most of you would do that naturally. Sometimes at the end, you do need to rewrite an improper fraction. Now, most of the examples do not have that in this lesson, but I am going to show you one at the end that you might see and go, wait a second, what would I do with this? So, just so you know, there's an extra step sometimes at the end. Otherwise, it's pretty normal. So, let's go through some problems. Lorenzo is making smoothies. How many cups of juice does he need in all? So, we have this recipe. How many cups of juice does he need? So, what equation could we write? Well, I do have to do some careful reading because it's asking about juice. So I need to look and say, oh, juice, juice. The other one's ice and yogurt. They're not asking about that. If we'd all combine it, right, to make a smoothie. So we'd have 3.5 plus 2 1/3 equals, we could say, P, pineapple juice, S for smoothie, right? Just amount of juice, J for juice. But we're adding those two fractions. That is, I would say, the key aspect that we're getting at here. So, let's go ahead and do that. And now, of course, that I wrote it, I'm going to immediately forget what they were. 3.5, 2 1/3, okay. Half plus 2 1/3. So, still going to find a common denominator. That does not change. 2, 4, 6. 3, 6, so we can use 6. If you need to write them out, that's fine. This one I multiplied by 3 and by 3, multiplied by 2 and by 2. Okay, add my fractions like normal. Add my whole numbers, that's the new step. So I get 5 5/6 as my answer. All right, not too tricky. Now, we're going to look at another sort of method because look at what Lorenzo did here. He did 7 halves plus 7 thirds, 21/6, 14/6, 35/6. What did he do? He just turned these into improper fractions, found a common denominator with those, and then added those together. Right? Then he'd want to change it back to a mixed number. So if you love improper fractions and you love changing them back and forth, by all means use this strategy. It does have some advantages, especially when we get to some subtraction with mixed numbers. I think for a lot of mixed number problems, it's just an extra step that we don't need to do, right? Like I'm going to be doing some bigger multiplication. I'm going to be doing some like fancy things, more room for error. But again, if you love improper fractions, you could change it to improper fractions, then add, and then get your answer. If you want more examples, I can show you. I'm not going to show you that way, but if you want more examples, I'm happy to do some for you. And like I said, it does have some benefits, which I can talk about when we get to a couple lessons from now. What is it, lesson 8? All right. Now I'm going to have you try one. 3 3/10 plus 4 2/5. Go ahead and give it a try. All right, hope you got it. I'm going to go over where I have more space because I love my space. All right, 3 3/10 plus 4 2/5. Find it kind of pleasant to go through these steps. I don't know, maybe I'm weird. So 10 would work if I use 20, right? 20 could work. I would just have to simplify more. Since 5 goes into 10, I can use that. That just stays the same. Times 2 and times 2, so I get 4. Adding them together, always good to double check. 3 plus 4 is 7. Denominator stays the same. So 7 and 7/10 is my answer. 2 more. This next one, 1 3/4 plus 5 1/6. Go ahead. All right, hope you got it. This one, we can't just use one of them because 4 does not go into 6, nor vice versa. This is also an example where if you're used to just multiplying the denominators together to get your denominator, not the greatest idea here. Also, you'll notice I don't rewrite the whole numbers. I do just rewrite the equivalent fractions. Just don't forget about your whole numbers. Sorry about that. All right. 4, 8, 12. 16, 6, 12. Sorry, sometimes I only go to what I knew because I knew the facts in my head. But if you don't have yours memorized, there you go. Times 3 and times 3. So I get 9. Remember, I'm just figuring out what did I multiply by? How many 4s did it take? How many 2s did it take? All right, add my fractions. I get 11/12. Add my whole numbers. I get 6. So 6 and 11/12 is my answer. Don't need to simplify that one. Now this one, I'm going to have you try. I made this one up. So 2 3/4 plus 1 3/5. Go ahead, give that one a try. All right, you might have gotten stuck on that one because something weird happened, right? I want to use 20 as my denominator. This one's times 5. This one times 4. If I add them, I get 27/20. Uh-oh, I got an improper fraction. What do I do? Because I don't like having a mixed number with an improper fraction. That's weird, right? I kind of want one or the other. I just want to take this and turn it into a mixed number. 20/20 is 1 whole, right? That's 20/20. I'm still going to have 7/20 extra. So just this part turns into 1 7/20. So then I carry this 1 over with my other whole. So I get 4 total wholes and 7/20. If it helps to think about it, if I didn't write this here, it's like I carry the 1 up into my whole number land, so then I get the 4. So I just had to take the improper fraction that I got from my fractions, change it into a mixed number, then combine that with the whole numbers that I already had. Okay? I can do more examples like that. I don't think there's any on your practice pages. And again, in lesson 8, when we do add and subtract mixed numbers with regrouping, we will hit that more. So don't worry if it doesn't make sense. Good luck on your practice. Let me know if you need help.